All right, so yesterday in the video, you guys did a little simplifying with trig functions, just practicing with these identities. And for right now on your identity sheet, this whole section all week, all we're going to use for this identity sheet is what you see in the top left, those fundamental identities that you really got in your notes back in chapter 5. We did a little bit with those, the reciprocal, quotient, Pythagorean. So we're going to be using those more with simplifying. You should have also written down one problem where you were disproving. You can disprove either graphically or algebraically. Graphically is where you graph it, show they're not the same. Algebraically is where you plug in a number and show that they're not the same, one or the other. And then today we're going to get into the actual proof part. Now, as far as homework goes, you guys have a packet for homework. You're going to have a packet or a couple pages, depending on what it is, for every section in this chapter instead of Math Excel. Math Excel is really difficult to use when we're talking about proofs and stuff, so we're going to do this instead. It's on your calendar when this is going to get collected. So actually the 6-1 and 6-2 homework are getting collected on March 2nd, so you have some time. It's going to be graded for completion, but we're also going to probably pick like 2 or 3 problems off of each packet to grade for correctness. We'll just grade, number, I don't know, 16 and number 40 or something on everybody's packet for correctness also. So you want to make sure you're completing every problem, asking questions as you're working through it, and doing your best to get them right. I can always check if you want me to. You do not want to wait until the day before to work on this homework assignment. We're going to start doing some proofs today, and practice makes perfect, literally. It's going to be seem very easy when Mrs. McDonald is up here doing it for you. But then as soon as you have a problem in front of you and you have to find that strategy and the correct one to apply, the correct way to each problem, it becomes a little bit more difficult. The more you practice, the easier it's going to get. So if you haven't started the homework yet, I would definitely start doing it. Maybe give yourself 20, 30 minutes a night. Get as far as you can into problems. If there's one you get stuck on, ask a question. We can do stuff on the board. It's going to be more so like a traditional math homework than what we've been doing with that. Okay, so, but I can help you on it if you have questions. Just work through a little bit at a time and don't overwhelm yourself when it gets close to the deadline, okay? All right, so yesterday you dealt with expressions. Today we're going to deal with identities, proving identities. So now instead of an expression which doesn't have an equal sign, we're going to be given an identity that we're proving which will have an equal sign. The equal sign that you see is going to be kind of like a question mark. It's an unknown if they're equal, and our job is to show that they're equal. So your goal when you're proving a trig identity is to make both sides look the same. If you can make both sides look the same by manipulating them using either trig identities or basic algebra, then you have proven the identity. Now this is a little different than what you guys did in geometry with like your 2-column proofs. We're going to be doing the math, but we're not going to in another column be writing reciprocal identity, quotient identity, naming the actual property. You're going to be in your work showing which property you're using by swapping something out or using foiling or whatever. As long as you show the work in every step, you're good. You don't have to name the property. Because the equal sign is an unknown, there are certain things that we are not going to be allowed to do. Pretty much anything that you would need both sides of the equation to do is now completely off the table. So for example, cross multiplying, you need both sides to do it. Can't do it anymore because cross multiplying assumes that we already know they're equal, which we don't. Adding something to both sides, subtracting something to both sides, moving something from one side to another. Those are all things that require both sides, so you can't do them. So what you want to think about is you want to think about each side of these equations as its own expression. We simplify the left as much as we can. We simplify the right as much as we can independently from one another and try to get to a point where they're looking the same. Now this slide is some options you can try. I put this on here so if you get stuck on a problem, you can kind of come back to this and see what applies to each question. This is going to be a few sections where I can't give you a step 1 do this, step 2 do this, step 3 do this, because all of the problems are going to look different. And the only thing that's going to make it easier is practicing, because you're going to start recognizing, oh, when this looks like this, I can use this strategy, and that's going to help it look like this. And you're going to notice that gets a little bit easier as you go. Okay. So what we're going to do today is we're going to practice a bunch together, and then tomorrow we're just going to practice more. Practicing perfect. Okay. All right, so here's our first identity. 1 minus sine squared over cosine equals cosine. We're trying to make one side look like the other side. The hint at the top here is to work with the more complicated side. The more complicated side, what has more stuff going on, gives you more opportunities to reduce and simplify, swap out an identity, that sort of thing. So we're going to work on the left side in this problem. What we're looking for is out of one of two categories. Can I substitute something I have there with an identity or another trig function? Or can I just use basic algebra to simplify this, like things you did in Algebra 1, foiling, combining like terms, common denominators, that sort of thing. So those are the two questions you want to ask yourself. Can I use a trig identity or can I use my algebra? So from what I have there, I notice I've got this 1 minus sine squared. If you have a squared, you should be looking at your Pythagorean identities. And this is an example of when those alternative ones are helpful. Because if I see this, 1 minus sine squared, it's equal to cosine squared, which means I can replace 1 minus sine squared with cosine squared. So I'm going to do that first. Okay, so now on the left, I have cosine squared over cosine. Now, pretend those aren't cosines, just x's. If I had x squared over x, what would you do with that? You it wouldn't be 1, it would become x, because you would be able to cancel 1 from the numerator and 1 from the denominator, right? Or subtract the exponents. You can think about it that way too, either one. But this is just basic algebra, right? If you've got something squared on top and something that's not squared on the bottom, you have a common factor that cancels. So if I cancel one cosine, I have a cosine on top, and I have a 1 on the bottom. And anything divided by 1 is itself. And that's what I needed to do. I have the left side now that looks like the right side, so you can always bring that down. And as soon as they look the same, you have completed the proof. And I like to put a little box at the end of it. When you guys look at like a math textbook, at the end of examples, they'll often put like a little symbol like this to say that it's completed. Makes me feel like I've accomplished something when I get to draw a box, but you can do whatever you want, okay? If you want to draw a flower or something like that, that's fine. Now, what you don't want to do when you're proving these is you don't want to just take this left side and write cosine equals cosine. The work is the answer to the problem. We're not so concerned about this last line because I can probably look at this and say it's going to end with cosine equals cosine. The work in itself is the solution. So even if you think it's obvious and you can do it in your head, write that step down, okay? All right, let's try another one. I've got tangent to the fourth plus tangent squared equals tangent squared secant squared. Now the hint at the top here is stay focused on the final expressions. So just kind of keep in mind what you've got on both sides. You're trying to make one look like the other. If I'm looking at this, there's one guy that stands out that doesn't fit with everybody else. Who doesn't fit? Secant squared. So ideally, I would love to take this secant squared and replace it with something better that's more like what I see on the left side. What could we replace secant squared with?
1 plus tangent squared.
It's a Pythagorean identity. Anything that's squared, look at the Pythagorean identities. I can replace it with 1 plus tangent squared. So I'm going to work on the right side here. 1 plus tangent squared. So that made it a little bit better. Now everything's a tangent in my problem. What could you do now, comparing the left side to the right side? Anything I could just do like algebraically to simplify either side? Not FOIL, but distribute. You've got something multiplied outside of quantity of parentheses, distribute it in. So tangent squared times 1 gives me tangent squared. Tangent squared times tangent squared gives me, what do you think? Something squared times something squared gives me 4th power. Yep. And then is that the same thing I have on the left side? Yeah, addition is commutative. So if we see tangent to the 4th plus tangent squared, we assume it's the same as if I swapped out those terms. End of proof. Okay, good. All right, let's try this one. Cosecant over 1 equals tangent over secant minus cosine. All right, so a hint here, and this is a strategy a lot of people like, is you can take any function and you can write it with sines and cosines. So sine and cosine are obviously themselves. Secant and cosecant are reciprocals of sine and cosine, and tangent and cotangent, you could use the quotient identities, sine over cosine or cosine over sine. This is a good strategy to use when you have a lot of different trig functions in the same problem. If I'm looking at this problem, I have 4 different functions. It's really difficult to make one look like the other when there's 4 different things all happening. So if I can take every term and at least write them with sines and cosines, I'm going to have more opportunities to combine and simplify what I have. All right, so let's start with the left side. Cosecant is what in terms of sine or cosine? Or both? It's what? 1 over sine. It's a reciprocal identity. Okay. What's tangent? Look at your quotient identity. Sine over cosine. What's secant? What's secant equal to? 1 over cosine. And then minus cosine. You can write cosine over 1 if you want. So everything's a fraction there. Okay, so I made it better in the respect that I've got just 2 functions now. I made it worse, though, because I've got fractions inside of a fraction, which make it a little kind of gross. So I always like to think about just algebraically, if there's something gross in a problem, how can I get rid of it? The little denominators in that fraction are gross. If I could get rid of those, the problem would be better. So what I'm going to do is I am going to multiply by the denominator I don't want. I'm going to multiply by cosine. That's the denominator I don't want. Now, I can't just multiply by cosine by itself because that changes what it's equal to. But if I multiply by cosine over cosine, what's anything divided by itself? Equal to 1. So although it's going to change the way it looks, when I multiply by something by over itself, it's not going to change what it's actually equal to. Now, you can do it like this, multiply a whole side by something over itself, or if you just have an individual fraction that you want to change the denominator, you could multiply by something over itself. It's just getting a common denominator. All right, so that first cosine is going to get multiplied into the numerator. The second one's going to get multiplied into my denominator. So on top, I have sine over cosine times cosine. What do you get when you multiply those together? Just sine. The cosines disappear. One's on top, one's on the bottom. Then I have 1 over cosine times cosine. What is that? 1. And then I have cosine times cosine. Cosine squared. Okay, so that made it better. Don't have the fractions inside the fraction anymore. Now I've got a squared. What group of identities are probably going to be helpful? Look at your Pythagorean identities. Do you have a 1 minus cosine squared anywhere? What's 1 minus cosine squared equal to? Replace it. Oh, and I have something over something squared. What can I do? Cancel one sign. It's a common factor. So what am I going to be left with if I cancel one sign? 1 over sine. And that's what I have on the other side. End of proof. Okay. All right, let's do a couple more. Let's try this one. Tangent plus secant equals cosecant plus 1 over cotangent. So the hint here is work on both sides. We've kind of done that a little bit in a couple problems already. But I'm looking at this and there's a lot of different trig functions, right? It's 4 different trig functions. So what are we probably going to start by doing? If you've got a lot of different trig functions, what's a good strategy? All sines and cosines. All right, so let's start with tangent. What can I rewrite that as? Sine over cosine. What about secant? One over cosine equals cosecant. 1 over sine plus 1. And what about cotangent? Cosine over sine. Okay, so now there's something we could do on the left or the right. Doesn't matter. Any ideas that could make either side simpler? Just algebra right now. Mm-hmm. Okay, good. So again, I've got those fractions inside of a fraction that are kind of gross. I don't want the denominator of sine, so I'm going to multiply by sine over sine on the right. Make sure you distribute it to every term, numerator and denominator. 1 over sine times sine, what does that give me? 1. 1 times sine, sine. Cosine over sine times sine gives me cosine. Okay, that's simpler. Now I don't have any denominators in the bigger fraction. Then what? Anything I could do on the left or the right to make one side look like the other? They're close right now. Yeah. You can add like terms here, right? You've got fractions, common denominator, add them together. Sine plus 1 is sine plus 1, or you could say 1 plus sine if you want. And common denominator stays the same when I add like terms together. Cosine, and those are the same fraction. We are done. Now, do I expect that when you start this problem, you know it's going to end looking like this? Absolutely not. So you are not going to, in your head, know the 4 or 5 steps that we used here to get from part 1 to part 5, right? You just have to pick a strategy and use it, and hopefully you get to a point where then it becomes obvious how to finish it, where it's going to end at, okay? But don't think that you're going to understand all the steps and visualize the whole proof in your head to start. You're just going to look at it and say, this strategy is going to work with this type of problem, so I'm going to try it, and if it doesn't work, you just erase it and try something else. There's going to be a little bit of trial and error when you're doing these. All right, let's do one more together. Let's try this one. Tangent over secant plus 1 equals secant minus 1 over tangent. So the strategy here is using conjugates. So we're going to see a lot of problems. There's a 1 plus or 1 minus, and those relate to our Pythagorean identities whenever we see a 1 plus or a 1 minus. But we can only use Pythagorean identities if we have something that's squared, which we don't in these problems. It's also very tempting when you see a problem like this to want to cross multiply. Remember, that is illegal when we're proving. They're not allowed to cross multiply. So how do I get my secants, for example, to be squared? Because if my secant was squared, life is good, right? I can replace it with some tangents. We use conjugates. Conjugates are the same term, but different signs between them. And you could do this on the left or the right. Just pick one or the other. It doesn't matter. Let's say I want to work on the right just because I have space there, okay? The conjugate of that numerator is secant plus 1. And if you multiply by something on the top, you better multiply it by the bottom as well, because it's like multiplying by 1. Now, anytime you have a quantity, a plus or minus, might be helpful to put it in parentheses. We're going to multiply these guys together. When you're multiplying fractions, just multiply straight across. In the numerator, I've got 2 terms times 2 terms. So how do we multiply that? This is just algebra. We're foiling. So my first terms are going to give me what? Secant times secant. Secant squared. What are your outside terms going to give you? Secant times 1. Secant. What about your inside terms? Negative 1 times secant. Negative secant. And then your last terms, 1 and negative 1. Negative 1. Now the denominator, if you want to, you can distribute that tangent in. I'm not going to, and here's why. That on the left has a secant plus 1. And I'm trying to make it look like this. So I want to keep these separate from each other because my goal down here is going to be to get rid of that tangent. Okay, so if you wanted to distribute it in, that's fine. It's not wrong, but you might eventually have to take it back out. So I'm just going to maybe look ahead and save myself that step. What happens in that numerator now? What happens in that numerator? Just algebra. What do you do after you FOIL? Yeah, combine like terms. You have a positive and a negative, they cancel. And now look what I have. I have a secant squared minus 1. Does that look familiar? What is that? It's a thing. Look on your sheet, find it, or look on the board. Secant squared minus 1 is equal to tangent squared. Replace it. Tangent times secant plus 1. Okay, now look at what you have on the left and look at what you have on the right. What's the difference between the two sides right now? There's an extra tangent in both the numerator and denominator. So there's two routes you could go right now. Route number 1 is tangent is a common factor of the numerator and denominator, so you can cancel one tangent over here. Option number 2 is you could, on the left side, just multiply by tangent over tangent and make it look like the right side. So you could do either one. This is where you're going to have some choices you're going through these. I will caution you, though, one of the biggest mistakes people make when they're doing these problems is they cancel things that can't cancel. Things only cancel in a fraction if it is a common factor of the numerator and denominator. So ask yourself this. I'm looking at that and I'm not sure if I can cancel the tangent or not. Could I factor tangent out of the numerator and denominator? Yes, then you can cancel it. If you can factor it out, you can cancel it. If you can't factor it out, you can't cancel it. Make sense? Because it's a common factor, I cancel it out, which leaves me with one tangent on top and no tangents on the bottom. And that's what the other side looks like. So I'm done. What questions do you have so far? None? Ready to try a couple on your own? Okay, let's do this. I'm going to give you, what time is it? We get out here at 51. Maybe 10 minutes. So you have until 12:42 to do these two problems. If you can't completely get both proofs, I'm okay with that right now. But I want you to get as far as you can into it, okay? Try something. If it doesn't work, erase it, try something else. The worst thing you can do for the next 10 minutes is stare at these and say, I don't know what to do. If you don't know what to do, find the slide with the options, pick an option that might apply, and try it. Okay, so you have 10 minutes to work. If you can solve one, great. If you can solve two, awesome. After 10 minutes, we'll come back together. We'll talk about them and look at some strategies that would work. Okay, and then all we're going to do tomorrow is practice this more. Go. All right. So here's how I would do these problems. That doesn't mean this is the only way to do them, though. Okay. So in the first problem, did you guys try sines and cosines? There's a lot of different trig functions there, so it's a good strategy. So it would look like this. Cosine times cosine over sine plus sine. And cosecant, you could even make 1 over sine. Yeah. Oh, it's not. Hold on. There we go. Better. I was writing. It just wasn't showing up. All right. So cosine times cosine over sine plus sine equals 1 over sine is what the first step looks like. A lot of you got that far. And then even you could simplify that first piece together. You can do cosine times cosine over sine, which gives you cosine squared over sine plus sine equals 1 over sine. So there's two things you could notice here. Number one, you could notice that one of those guys isn't a fraction. So I would maybe want to make it a fraction. It's the guy that doesn't fit in the middle, right? Another thing I could think about is on the left side, I have 2 terms, and on the right side, I only have 1 term. So the only way those are going to ever look the same is if I take those 2 terms and make them 1 term, if I put them together. So that's going to be my goal. I'm going to work on the left side. I'm going to try to put those together. Well, what do you need to add fractions together? Common denominator. What is the common denominator? Sine. So if you think of this like a sine over 1 right now, the first fraction's good. Don't touch it. The second fraction, I'm going to multiply by sine over sine, just to get a common denominator, which is just like multiplying it by 1. So it's going to give me cosine squared over sine from the first fraction plus sine squared over sine. And now because I have a common denominator, add them together. So cosine squared plus sine squared. Denominator stays the same, sine. And now there's something you should recognize there. Cosine squared plus sine squared is 1 over sine. And I already have 1 over sine here. End of my proof. Okay, good. All right, on the next one, I would notice that everything is the same except that secant squared is probably going to need to change into a tangent. So secant squared is equal to 1 plus tangent squared, using the Pythagorean identity. I could also look on that left side and say, I'm going to have to FOIL, right? I have two terms that are squared. So if I FOIL, I'm going to get 1 for my first terms. My outside and inside are both going to be a tangent, so you could just do that all at once and say plus 2 tangent. And then my last terms are going to be tangent times tangent, tangent squared, and then that's it. So you could do that in a different order. You could FOIL first and then take the 1 plus tangent squared and turn it into a secant squared. So your ending line might look different than my ending line, but it's probably the same steps. It probably at some point you used a Pythagorean identity and you FOILed, were the two ideas there, okay? All right, all we are going to do tomorrow is practice these. And we're going to use the devices tomorrow. I've got this website we're going to use called Formative. Have you ever used that before? So basically there's going to be like 8 proofs and you and your partner can pick which ones you want to try. And as you do a proof, I can on my screen see everybody's work and check them and give you guys feedback as you work through them. So we're just going to practice more, okay? What should you do tonight? Try some problems, okay? Even if you only get 1 line into it and you get stuck, that's a question you can ask me then. It gives you something to go off of, okay? So try some of the problems. That first page in particular, it's not even proofs, it's just the stuff you watched in the video yesterday, okay? All right.